All right, you guys, so it has been a while since we did chapter 8 on trigonometry. And we reviewed special right triangles last week for section 10.3, right, when we did 30, 60, 90, and 45, 45, 90 triangles. So that was kind of the first part of chapter 8. Trigonometry was the second part of chapter 8, but had more to do with right triangles, right? So we're looking at our right triangles here and using some ratios for them. So remember in trigonometry that we want to make sure we're starting with one specific angle. So here I'm starting with angle A, as you can see in all of my ratios here. And then we want to make sure that we have all of our sides labeled. So C is always going to be the longest side, the hypotenuse across from the right angle. The opposite leg is going to be opposite from the angle, right, that we have selected, which is never going to be the right angle. It's only going to be, the one of the other two acute angles. And then the adjacent leg is always going to be the leg, not the hypotenuse, that's kind of running up into that angle there, okay? So remember we said SOH CAH TOA is our nice little name to kind of remember the order of the ratios. So sine of A, sine of that angle A, is the opposite number over the hypotenuse number. The cosine, not the cos, but the cosine of A is the adjacent over the hypotenuse, and then the tangent of A, of that angle, is the opposite leg over the adjacent leg. Just a quick reminder of SOH CAH TOA and how we kind of set up those ratios. Then a couple of steps for finding missing sides and angles, because we're going to need to be able to do both next week. These are steps I literally, you guys, just took this off of my 8.3 PowerPoint. So you might have these in your notes already, but I just want to kind of give you guys a little refresher. Step one is that we're always going to label sides from the known angle, or like the angle that we're trying to start with, right? So on that last slide, we were using angle A. And then we're going to pick, do we know enough information for sine or for cosine or for tangent? So we'll kind of decide from there which trig ratio we should use. Step two is to plug in any known information. And then step three is obviously just to solve for the variable, isolate it and get it by itself. So for finding angles with trig ratios, remember that we're going to have to follow steps 1 and 2 where we set up our sides and we plug in the information, but then we use that thing called inverse trigonometry to isolate the angle. So examples 3 and 4, I believe, have the examples with the inverse in them. So you can see those in just a minute. Okay, so example 1, here we go. I'm just going to walk you guys through these. Again, if you feel pretty confident or you think you know what you're doing, feel free to kind of like skip ahead to where I show the answer. But if you need some good review, I hope this is for you. So we're looking at this angle, 50.1 right here. So if I go through and label the sides, my hypotenuse is right here. I don't have any information on the hypotenuse. I only have information on this x side and this 5 side. So from 50.1, x is the opposite side, 5 is adjacent because it's right next door to it. So our first step is to set up our trig ratio. Because I'm using opposite and adjacent, I actually kind of skipped over step 1, didn't I? But our first step is to pick actually which sides we're using and then decide that we're going to use tangent, right? So now that I've decided I'm using tangent with my opposite and adjacent, I'm going to say the tangent of the angle, so the angle here is 50.1, equals the opposite x over the adjacent 5, right? So I've set up my trig ratio there, and I've plugged it in everything that I know. So then remember, we need to get it to the calculator ready answer. So in this case, I'm going to want to go through and multiply both sides by 5. That way I can isolate x and get it all by itself. So voila, I have isolated x. And then in my calculator, I'm going to want to be able to type in 5 times the tangent of 50.1 equals x. So remember, there's different calculators have kind of different methods for typing stuff in. So unfortunately, I can't like run you through a calculator tutorial. But feel free to reach out to me on Teams. I've had a few people send me like pictures of their calculators and say, how do I do this with this specific calculator? If you send me a picture of your calculator, I can totally walk you through the steps to plug this in. But if I plug it into my calculator and I round it to the nearest hundredth, because remember that was kind of what we rounded things to in our chapter 8, I get the x is approximately 5.98. Example 2. So on this example, we're looking for actually the hypotenuse here, which is x. So again, I'm going to go through and label my sides. I know this angle here is 57. So 10.8 is opposite, x is the hypotenuse, and my adjacent side is really just, there's nothing there, right? So I can't use tangent because that's opposite over adjacent, and I can't use cosine because that's adjacent over hypotenuse. So my only option here is to use sine. Okay, so I know that sine of 57, right, the angle is 57 degrees, and then it's going to equal 10.8, the opposite, over x hypotenuse, right? So that's where it gets a little bit tricky because now we have x in the denominator. Remember that we can't just multiply both sides by 10.8 and, be happy, be done with it. We're going to actually have to multiply both sides by x in this case. because we have to get x out of the denominator, right? So let me see if I can kind of squeeze this in here before I show you the calculator ready answer. If I have x times the sine of 57 and it's equal to 10.8, remember that the sine of 57 is actually just like a number, right? If I plug it into my calculator, it's going to just give me like some random decimal number. So to get x by itself, just like I would with a normal integer or decimal number, I'm actually going to have to divide both sides completely by the sine of 57. So now my calculator ready answer is actually x equals, right, because I got rid of all this stuff up here, 10.8 divided by the sine of 57. When I plug that into my calculator, I got 12.88. So again, if you need help with your calculator, please send me a picture or send me a message in Teams or an email, and I'm happy to help. Example 3, we're trying to find the angle. So this is the one where we're going to need to use the inverse trigonometry. So if you see here, we've got our opposite side here, 11.9, and our adjacent side here, 10. So I'm going to set up my trigonometric ratio. Using opposite and adjacent, I'm deciding to use tangent. And remember that theta is just kind of this fancy little variable, and we're just going to pretend that it's an x essentially. So it's 11.9 over 10. Now this is the step where we have to take the inverse tangent on both sides, right? So in order to actually get rid of tangent here, we have that thing called inverse tangent that looks like tan -1. But we read it as inverse tangent, and then I do tan -1 on this side. So they cancel out on the one side and leave you with just theta, right? So I have just theta on this side, and on this side I have the inverse tangent of 11.9 over 10, right? So I have to go inside the parentheses. So now, usually when you plug this into your calculator, if you have like one of the more basic scientific calculators, you're going to have to plug in the 11.9 divided by 10 and hit equals and get that decimal first, and then hit inverse tangent. If you have one of like the big fancy graphing calculators, you can just type this all in at once. Inverse tangent 11.9 over 10. So I got approximately 50 degrees. And I think in the past I've done round to the nearest degree, but you can totally do it rounded to the nearest decimal or like hundredths as well. Finally, example 4. Remember that theta, again, is just a fancy little variable. Treat it like x. So if I look at my sides that I have here, I have nothing opposite. It looks like I only have adjacent and hypotenuse. I'm going to set up my trig ratio. I'm using cosine of theta is 12 over 13. Again, I'm going to need to do inverse cosine, which means I use that little -1 thing there. So again, and then I'm going to do inverse cosine on this side. Okay. And notice that I don't put the inverse cosine over all the way to the right over here, right? Because really we have to do inverse cosine and then stick all this stuff inside of the parentheses. So technically it's supposed to go to the left there, which is kind of not what we do when we multiply stuff, but it does sort of matter in this case. So my cosines are going to cancel each other out and leave me with only theta on this side. Yay, that's what we want. And then over here I have inverse cosine of 12 over 13. So again, you're going to want to plug it into your calculator, and it's going to look different for everyone. And rounding to the nearest degree, I got approximately 23 degrees, but again, you can leave it rounded to the nearest hundredth if that works for you.